So this will be interactive talk, so everyone can participate who has a mobile phone. And so as I go through the talk, we will have several steps which everyone of you takes. And so I will do a presentation, sometimes talk something, and sometimes you do things. So first of all, switch off your internet, because like this presentation is about connectivity without internet. And then connect to Wi-Fi. So I brought my own Wi-Fi so that all this works. So please switch off the internet, because else you would have problems with domain resolving and so on. So yeah, so connect to the BMX and 4G Wi-Fi. It works best with Android phones, but iPhones should work as well. Okay, that's the first step. Now I got to introduce myself. So I'm Volker. I had a first contact with you about 15 years ago. I love offline first things, which is kind of like also similar to what this talk is about. And back then I did a bit of technology, and these days I work for protocol apps you might know for projects like IPFS, IPD, or UDP. So the goals for this talk are: you learn about WebRTC, you learn about content addressing, P2P networks, you get a glimpse into IPLD and IPFS. Also the reason why I speak so fast is because there's a lot of things to cover. And of course we get excited about the direct browser-to-browser communication. Alright, next step for you is go to this IP address. It said that it's just an IP address, but I can give a whole talk about like why I can give a proper name and so on. So if you want to hear about it, I will hear it.
What you said which you connect to?
VMX and SSD. And what we then should see is, I quickly, so I will also do here so that people can follow and see if they do the right thing. So it will also ask you for your, so first is an SSL certificate. So you need to accept, yes, it is secure, I trust the person. And then you also need to accept the camera because, well, we need to scan QR codes. And then who doesn't miss scanning QR codes all the time? So
what's the last number?
And this is a 50. That's a 54. So it's 492-168. Oh, I can go to the.
Yeah.
Sorry. Yeah. And then you will get a screen, and basically don't start scanning yet, because this will be the next step. Alright. So I hope, I have to go on, but I can also ask the other people if it doesn't work. So, core part, one concept of this is content addressing. So what does content addressing mean? I start with the opposite thing, which is location addressing. So location addressing means is what you are all used to on the World Wide Web. So you say, I go to a server / some URL, and this is like where that is. Content addressing is you ask about which data you want. So you just have an identifier, and you don't care about where this data comes from. And this is basically where all this comes in, because once we are all connected, what you will do is you will just say, oh, I want this data, you get it from someone. You don't know actually who it is, but you will just get it. And that's done with the identifiers are basically a hash of the data, or also sometimes known as a checksum. And the advantages is, so a real world example is also quite abstract, is a real world example is if I say I give a recommendation about a book, I give you the ISBN number, and you immediately can get to the library, buy online. It's super easy. And the ISBN number is content addressing. In the location address, what it would be, I tell you, oh, I love this book. It's in my hometown, in the library, on the second floor, in that shelf, the third book. And this is where you see the problems of location addressing. If the book is not there, you don't know which book I was talking about. Or this is the wrong book, and you don't know that you need some other book. So there you can see the advantages of content addressing versus location addressing. Alright, now we get to the first interesting part. So we are scanning each other. And some notes there. So you always need to scan one person, and the other person needs to scan you. So this is a one-to-one relationship. And I will do this.
There was something to scan.
And wait before you. So both things at the same time. Wait. Security. Okay, then I can someone here. Okay, so
so this case then
It's like the kindergarten. That's the major response.
That's all connected.
I have also taken problems. Yeah, so it's a short. Yeah, so if it has to connect, then try to reload and try it again. That's right. That's the worst case scenario. So I will try it again. Yeah, so this is what it should look like. So if it works for you, this is the exclusion. Does it work for you? No. Has anyone already the screen?
No. It's in the.
Anyone? Okay, I will go on with my phone, my laptop, and say like, yeah. That's it. But we can try afterwards again. I will be here till Sunday, so yeah. But I will go on with my phone. But I can still show you the results because I have on my phone and on my laptop. So, yeah. Sorry for this. I really tried it like a billion times. Alright, so the technology used in the background is called WebRTC. And it's already over like 10 years old. Yeah. And you probably know it from video conferencing like HTTP, for example.
That works when
Oh, great. I was quickly scanning with other people. So this is how I get off the camera. This is an iPhone. Yeah, so I put it without with the yeah. So I can use because we are That's great. Please don't download the page, but just leave it. Okay. Alright, so the interesting about WebRTC is it's not only the video conferencing, but we can also use it to transfer data. This is what we're doing here. Usually, the WebRTC is way too low level, so if you program with it, you usually use some aspects on top of it. So how does WebRTC work? Usually, so here we have Alice in box. So Alice starts and creates a so-called offer. And you send it to the other person. This then processes the offer and creates an answer. The important part here is that it's based on the offer that was sent. You create an answer. Then you send the answer back, process the answer, and then the browsers connect to each other. Now you might wonder, like, that's not what we were doing. Like, we were just getting QR codes, scanning each other, and it worked. This is supposed to work. And so what we are doing here is we really just scan each other, connect to each other, and it's established. So it's kind of different from what I just said. And this is what's called munging. It's outside of the standard, but it's supported by all browsers because it used to be possible before it was an official standard, so they still have to support it. But that's also the reason why it sometimes doesn't work, because like it's outside of the specification. So what munging means is you take the dynamic data, like your IP address, and then reconstruct the data that you would want to send, usually if you do it by the standard, and then just fill it out and do locally. I will get into more details on the next slides. So what we do here is we have those QR codes, and as you've seen, they are relatively small because they only contain the data that we actually need, and not all the other stuff that usually you need for WebRTC. So what does it look like? So what we do is Alice and Bob creates already a munged offer. So because WebRTC is also about like passwords and usernames, we just have a hard code. So the application just hard codes a username, a password, and we both use the same one. Then we scan each other with that information, and on Alice's side, based on the data that she scanned, she's munging the answer that Bob would have given if he would spec comply, he created the answer and processes the answer. What Bob does on the other side is he manages the offer. So he knows what the offer would have looked like if Alice would have sent it to him. Creates the offer, and then processes the offer. Once that is missing, because it was about like offered answers, he then creates the answer, the same one as Alice created by her own. So it's really the exact same bytes. But as you can see, they do it completely separately, independently. And this way, you can basically just scan a phone, click on connect, and it works. One problem we have there is, as you've seen in this workflow, is like Alice involved in different things. But how do we distinguish between, like, if I scan, let's say, Christian and we scan each other, who is Alice who's involved? Like, how do we determine it? The way we do it is, I create two connections. One is kind of like the Alice-like connection, and one is the Bob-like connection. And then we decide which one to use by an ID we create. So in the background, there's a little bit running, which I did for a layer, and you get a unique ID. And so if the ID from your own phone is bigger than from the other phone, you are kind of Alice, take the Alice part, and if it's smaller, you're the Bob part. And this way, you basically have two independent phones, and they can create a connection. All right, now I need to show this one on the screen, and I hope it still works. So I click on that. So Sally, can you use so you click on that. And yeah, you see here my snap. You can guess what it is. Yeah, so, and I just zoom in somewhere, and then I click on draw. And I can draw, so basically tap, and so that's where you can click on that, yeah, click on that. And then you can just draw, so it's basically tap and drag, and then you can draw like some nice polygons. Let me quickly do it also on my phone, so because then you will see what happens. So, okay. And now, and now comes the most exciting part. And now hopefully it works at least with one more person. So now we click on sync features. Okay, I will also click on sync features. Let's see. Let me zoom out. Click again on sync features. So now there should be features showing up on the map. Okay, that's also didn't work. But so just imagine now, features are popping up everywhere. Let's go everyone in the room. Isn't it exciting? So those are all features like they popped up everywhere on the map. And yeah, so this is how it should work. And the nice thing is you could then delete features and synchronize again, and your own features will then disappear. Alright, so that was the sync feature stuff. I will quickly go into like how this actually goes to the background. I've mentioned I use some computer technology. So one thing is about like how is the data structured and how you get to those things. So I think what IPLD stands for IPL interplanetary data, but I would just say it's about coded address structured data. It's basically just JSON, but you can also store binary data and links. I come to the links later, that's the important part. You can easily transform GeoJSON to IPLD. Then you will get a CAD. CAD means coded address identifier. This is what I mentioned earlier. It's just the hash of the data, and this is how you can identify features. Every such feature has such a CAD. And then, once you click all those features together, you will then create an array of those features. This is how the data is structured. And then you use libp2p, another protocol for where we use the publish this feature. So what you do is you create from this array of CADs, you treat it again like kind of like JSON like IPLD, and create a single CAD of it. And this is what we then publish to everyone. So this is what, if it would have worked, is if I click on sync, I say to everyone, oh, I have this new CID, this new identifier, please check it out. And everyone would then check out the CID and say, oh, I want to get all those features. And this is again about content addressing. You would just say, I want this identifier and get it from someone. So ideally, you would have put a long chain of peers and it would get from someone automatically to me. And finally, you want to store the things. So locally, you run an IPFS node. And you would then request the data. And the nice thing, again, about content addressing is, if you already have the data locally, you won't request it again. So it's kind of like more environment friendly because if you have the data already locally available, you don't need to get it again. So let's say, for example, someone changes the data and deletes features and says, oh, I have a new list of features, but you have them already, all of others, all the other features. You would just get them locally and you don't transfer any additional data. So the last step is partial, but we can try it at the end. So now what I also have the topology. If you go back, so if you go back on the map, and then into the topology, so what you see here is, so these are basically to my machine. It's connected my phone and probably Katrina, so basically we are 3 years connected. So ideally this would be like the whole room connected like everyone. Yes. So quickly about the limitations. So it works only when you are within the same network. It doesn't work if you kind of like remote and there's some switches in between. You need to basically in the same IP space kind of. Then there's a problem with the Safari. Sometimes it works, sometimes it does not work. I've had it working in the past. And sadly, what also is really not possible with the standard WebRTC is when scan bar appears at once. So ideally what I would want to build is basically I have a QR code and then 5 people scan this QR code and then the next person scans 5 people's and so on. This sadly doesn't work. It's a limitation of the standard. But there is work on it and it might be possible. So my guess is basically if the standards body agrees on it, it takes about like 5 to 10 years and that's really useful in browsers. But we'll see. So perhaps we see each other again in 2033 and I will give the demo and it will be run way smoother. The chances, so why are we doing this? I mean, it's a prototype, but the interesting thing is really cross-platform. You just need a browser. And everyone has a browser installed. You don't need a special app for it. And Wi-Fi is way easier to set up than internet connectivity. So I see in the disaster response use cases where you basically have no infrastructure at all, and it's just easy to place a router there, and just connect the people. It will then go out in the field, collect the data, go back, click the sync button, and get the data back. And then perhaps someone at home goes home, then there's internet connectivity, and that's with the others. Or if you don't need local internet at all, so for example, a team game called Space Team that we played at the FOSS which always broke because there was no internet connectivity. But you don't need it because it was a game which you locally play with each other face to face. So for such cases, it would be great. Alright, that's all I have. Try it later on with some people. So basically the cloud works also like from power banks or from my laptop, so just like catch me and then find some other people and we can just try it again if you feel like, yeah, I'm on the drop on Sunday, so perhaps it works then.
How that VMX, is that you route in your laptop or where does that network come from?
Yes, the network comes from here, so I can here. And yeah. Okay, are there any questions? So do you have questions about about WebRTC or like any other things? So if you don't, I mean we still have like 5 minutes, so you can just try it again quickly.
Yes.
Okay, let's try it again. Okay. Alright, so I will walk you through like, okay. So,
Should we refresh the page?
no, that's fine, that shouldn't be important. So, the problem is often like ideally you have 5 or 5, no, it doesn't matter. So, you need to refresh. Best is if the browser supports hard refresh. So I know on Firefox you can press the refresh button for a long time, it will be a hard refresh. That's even better. But start at just like here. So it's 192 there. And also make sure you have your internet disabled because like you might not be able to connect otherwise. Okay, so I also do it here again. So 192, 1.
It did. So
168, 050. I can also go to the slide. Where is it? Yeah. So that's the appearance. Alright, let's try it again. So I do have that. But you can check out, you know, this doesn't have using that. Yes.